Hey guys, welcome back to the channel. I have a ECM test. This time it's in a 2004 Toyota Camry sent from New Jersey. Samico Transmissions shop. They sent this computer because they said they have code P0776 and P0746. So as you all know, I already have all the solenoids that are taking place in order to check these computers properly. And I'm going to show you the test in here. All right, so I have the computer open as you see. I have their covers in here so they can see that this is indeed their computer. And they put a big number here that doesn't actually add up. As soon as I put 2T1BE, as soon as I click on that 3, something is not right, or I'm missing a number, not sure. Let me see how many digits they got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So yeah, it is a 17 digit, but something is not right. I couldn't use it. But I mean, with the 2004 Camry, it's all I need to really do the test. Yep. So you can see the connections. I have the solenoids are taking place to do the shifting. I'm gonna get an image in here so you guys can see are SL1, SL2, and S4, and I have it in here. Well, this is a business, so I don't think they mind. But yeah, so I got the S4 in here, the S1, and then S2, just because it's easy for me to plug in. I have the oscilloscope connected to all of them. So I have blue channel into SL1, red channel into SL2, and then the green channel onto S4, sorry. So those are the the 3 solenoids are taking place. I can show you, well, I have shown in multiple occasions these connections. I can make that image bigger, probably the best for the show here. So let me make this just a little bigger so you guys can see it. So connections that I need to check this computer here is powers in connector E6. I also have marked, and you can see this here, the connector positions, because I don't have the vehicle, right? So 6, 7, there is a empty spot on the center, and then 8, 9, and 10. And that's what it refers about E6 or E8. That is connector. They just name the connector all E's and then just change the numbers 6, 7, 8, 9, and 10. All right. Okay, so again, powers in E6, 1, 6, and 9, those are ignition. E6, 3 is battery or constant battery. I also have a ground in E8 or grounds on E8, 1, 4, and 7, and then in E9, pin 7. The DLC for this specific computer is on the communication is on E6, 18, DLC 7. And it's talking good. We will see that on the scanner in a second. And I also have other signals when depends on what I'm checking. You know, the most common problematic areas. We got the ignition coils, injectors, the IAC, the coolant sensor, air temperature sensor, and the park neutral position switch, which are also problematic signals that need to be checked sometimes in the vehicles or in the computer. Sorry. All right, so I'm going to leave that image here. And now let me get the meter or the picoscope that I have ready, and also the scanner. So I have been doing a test and I don't really see anything wrong with this computer. So with the Snap-on, we can do a complete check. This is supposed to be done in the car running, and you connect an oscilloscope the same way that I have connected. So you can go over to each of those signals at the transmission or or at the computer, whatever is easier for you to reach, and you're supposed to check this up. And also you can check for resistance on the oscilloscope, resistance on the wiring, etc., because those are very important. It is very crucial to check the grounds on these computers. It's a known problem that sometimes give these fault codes, again the codes P0776. I'm going to show you also an image where it shows what those are. So let me just get that one in here before I might have it pretty much ready to go. So just give me 1 second. Yeah, I can move it over to the display. and I'm not sure where you're seeing, so I need to try to connect the iPad so I can see what you guys are seeing. All right, so this is from Identifix, one of the text. I mean, there is multiple informations in here, and you can see that that fits a lot of cars like the Camrys, a Highlander, Solaras, with the same um, transmission. All right, so P0746 is related to control a solenoid, and that is SL1. And then P0776 is for SL2, and that's for solenoid B. And that's what, it will be said. This guy in here put, that this is a mechanical and not an electronical or electrical code, and I have to disagree. Especially, I repair multiple of these computers and the RAV4s and the Camrys, and I end up being 100% the computer, or let's say not 100%, 90% of the time the computer. I have another images in here. This is kind of like the flow chart, so you can see that, where he's getting all this information. This is not like that he find out, but there's multiple other ways or that this fault will set. And as you can see here on the first one, P0776 pressure control B performance, and that is very specific to the solenoid SL2. And that could, as you see here, this is from the manufacturer. It remains open or closed. The valve body is blocked. The chief solenoid valve is bad and is not being actuated, even though you can, sometimes you can even hear the click, and that's not pulling the plunger. So that's why its visual inspection is a must on this one. It could be the automatic transmission. It could be the ECM. So you see in here, they have 5 different approach for this same fault code. All right, let's go back to here. And let me put, again, the Pico and the... I need a picture. Perfect. All right, so you will be able to see the shifting, because with the snap-on, as you can see here, I'm in a test plan. So I'm going to go back just 1 second so you can see where I am, because this is not very unique on a snap-on, but very easy to find this way. So when you're here on the computer, well, firstly, I also want to show that I don't have neither of those fault codes in here. And if it will be a problem right now that is happening here, the computer will be setting those fault codes. So let's go over the history. I've been running this for a while. So as you can see, there is no P0776 or 746. So there is nothing of that. And I can go back because I'm right now in the transmission. Those are history. Let's go into current. And you can see there is cam position sensors and other fault codes there, because, those are not connected. I'm, doing a test for the specific concern that he has on this vehicle or in this computer. And that has nothing to do with this. I can enter, I can get out of here and then go over to the engine computer, and let's check the codes in here. Not sure why they separated this, or Snap-on did separated the computer into engine and transmission when they're the same module. All right, let's go over to history codes and see if we have anything different. And we can see how we go from P0504 to P2135. So a 0700 is not here for neither one of the transmission. So let me just, this is only related to the engine. So let's go over to the transmission again one more time. So I think that you can do this 2 ways. You can go into actuator tests, shift, again, it's an old computer, so we don't have the CAN bus communication in here. It's asking you to confirm that the vehicle speed is greater than 30 miles. Sorry, that the vehicle speed is less than 30 miles an hour. Yes, it's less. We're not moving, so that is okay. But yeah, so you can enter this way, or you can go over to troubleshooter. So we are in the same spot, right? So let me just move 1 second up in here. I'll make sure that I am recording the full up in the oscilloscope, and I don't see an image in there. Sometimes that happens when I'm moving things around. So let me reselect the Pico. Pico. Not sure why it's not showing image. Oh well, because it's nothing in there. I think it's the Pico that, yeah, Pico is now running, but it's no lines on the scope. Sometimes it does that, I'm gonna have to reopen it. 1 second, guys. Should be already saved. Looks like it's not picking it up. Yeah, it's not on for one reason. So let me just double check that, guys. All right, guys, I have to actually restart everything because, yeah, the Pico scope wasn't trying to pick up. I have to change the wires and everything. But, yep, sometimes electronics are just like that. So I turn the computer off. Either way, it's important to do that sometimes because these solenoids will be running. And there, since they're not in a fluid, I mean, they're very robust and everything, but I don't want to keep it going without need. Let me just make sure that everything on Pico scope is as supposed to, because I reduced the size of the display, yeah, so that we can see the signals all into there. All right, so let me turn the computer on. As you see, blue and red channel. Again, the blue is solenoid 1, red is solenoid 2, and green is S4. We have that picture in there so you can see what it should be applied when we're doing every shift. So let me get into the scanner. I'm going to go over to, we were in an actuator test. If you go to troubleshooter, transmission, you can also get into here like a test and procedures. And then you can go over to, let me just see, functional, no restriction or test the part. What's here? Transmission service, no. Functional test descriptions, yeah, right here. Functional test descriptions, and then shift gear enable. See, this is describing what will happen, and then when we click in here, all it does is go back to that same test that I showed you. So now you know 2 different ways to access that same test. And I like that from a Snap-on. And a Snap-on troubleshooter for beginner is a great tool to have because it will add a lot more information that otherwise you will not get. All right, so this is again just warnings in here. So I'm going to be putting the computer into each shift. So first is right now applied, so that did not change. So I'm going to go over to second. Actually, you know what? Before I do this, let me change the time frame to, let's do 2 seconds per division. Like that, you guys get to see the whole change in the screen. I'm going to wait for that screen to start again. It's just going to take like 20 seconds, but no problem. I can always talk, right? All right, so but as soon as that restart, I'm going to go from first to second, then third, fourth, back to third, back to second. So let me do it now. So second, third, fourth, back to third, back to second, and then first. All right, so I'm going to snap that so we can go back to that capture. I'm going to turn the computer off so those solenoids don't heat up. We might lose the communication at the bottom, and as you can see, we did because I turned the computer off. Again, I don't want that to get overheated. So I'm going to exit in here because it says command fail. I guess we can stay here, so that's fine. All right, so right now in this screen, let me put that one into my screen so we can all see the same. The first part, we have the 2 blue and red completely steady. When I go into second, so second should be blue off, red on, and then green off. And first gear, let me start for first gear because we will come back to that one. So first gear should be red and blue on, which is that big bar that you see, and then green off. Off is low, as you can see from the center of that capture, right? So when we go into second gear, we should have blue off, red on, and green off. And we can see that indeed happening. When we go over to third, and the only reason we see a little bit of activation on the blue channel is because the car is not running. So but we can see immediately how it goes off, because in third, all solenoids should be off, right? So we can see how red goes off, but blue, it goes like on and then off. And the only reason, again, is doing that is because I don't have the actual shifter. So I'm selecting this through the scanner. There is no miles per hour, no RPM. So I'm not really fulfilling the entire test, but the shifting are happening. And why am I saying that is because if you see then, like, and this is milliseconds, right? So we can see how the blue channel goes completely quiet, like no signals. And I will zoom in a second so you can see the actual activations of the solenoid, how they look. I just want to describe what we're seeing in the screen. So then I apply the 4th gear. And if we go over to that image on the left upper side of the screen, the last one was said, overdrive 4th gear, right? We have red and blue should be off and green should be on. And that's an on and off. It's not like the other ones that has a pulse width signal. And that's what you see all that bar like that is because it's being pulse modulated. But so we see on and then red and blue off. Now I go back to 3rd gear, and then we can see when we have that coming from there, 3rd gear all go low, stay low, even green, right? Then when I go back to 2nd gear, on 2nd gear we should have only the red on, and that is when that blue, it gets activated for like a millisecond, and then we have that red channel on, and then it goes off. So that's definitely the commanding being in place. And I also want to address this because you're going to say, well, that might be the glitch, that blue actuation, and I'm going to show you that it's not. So I'm going to go back to the picoscope. I'm going to turn the computer back on. All right, so we're in picoscope right there. I'm going to go to the scanner. We're going to enter the test one more time. But right now they're just on, and I'm not in the screen. I'm just going to go first, second, first, so we can get to see that is indeed nothing wrong. It's just, again, that I don't have all the signals in here. But all I really care is to make sure that the computer can command them on and off and on the right time, and there are. So again, I'm going to wait for that screen to start. I can actually restart the capture, so let me do that. Probably it's faster than waiting for that. So. All right, so we're going to go first. We are in first. We're going to go into second. You can see, and then go back to first. I'm going to let it happen, but the computer will do it. You see? The blue never went on when I go first and second. If I go first, second, again, one more time, it stays on. And then when I go to third, you see, it's like for a fraction of a second, it goes off because the all should be off. But that is just, and it will come back. You see right there with me, I didn't touch anything, and it went back to first gear. It's a timeout. And the reason that it's being timeout, I'm going to turn the computer off again to not let it warm up. Let me get back to picoscope. And the reason it's doing that is, again, because it's a test. It's not a running vehicle. So we're only looking for the actuation. So right now, what I want to show you is indeed I'm going to zoom into these two signals, the blue and the red, so you get to see the actual pulse width modulated signals taking place. So right now we got solenoid 1 in the blue, right? And that has not changed. And the solenoid B, or SL2, in the red channel. And we can see how we got that on and off, on and off, on and off, on and off. It's happening very rapidly. This way, the manufacturers find out that is the easiest way to keep a solenoid open with less amperage, and that will elongate the life of everything. It's less load onto the engine, like that is less fuel consumption, right? Because an alternator, in order to produce power, it has to be moved by what? By the belt, by the engine, right? So that is reducing emissions. And at the same time, okay, well, if we can make those valves open and close, or keeping it open, right, by less amperage and less voltage, well, that is saving, again, space, right? So that is why they do that. But yeah, so all these signals are looking completely good. I don't see absolutely nothing abnormal. And this is where I always try to share this, because I got, actually, when I paused the video, this customer called me, and Mike is like, is anything you can do with the computer? And then maybe send it back. I'm like, if you want, I can refurbish the computer, but that will not correct your issue. The P0776 and 746 will be there no matter what I do with this computer, because there's nothing wrong with it. Yes, I can replace capacitors and diodes, and that will be, a charge to repair, refurbish a computer. That is nothing wrong, but it will elongate the life, but not to correct any situations. And he's like, no, I don't want that, because I need to correct the problem. Exactly. So I am not going to repair something that is not broken. The problem is not here, it's on the car. All right, guys, so I hope that you like the content. I am always looking forward to share these videos and connections. These are always very easy to do things, and I explain connections as far as powers and grounds, where the communication goes. I have an OVD port connected into this universal box that you don't really need. They sell these harnesses. Let me just show you. They sell harnesses like this. Let me get to the the microphone. They sell harnesses like this, but instead to have this 25 connector in here, which is for my box, they have a OVD port in here. And they have powers and grounds with a switch where you can turn the ignition on and off, right? But then you have all the DLC pins, because on the DLC connector, you got powers and grounds, and you got, CAN bus, CAN high, CAN low, KL7, PCI bus, and so on. Other buses there are, how the scanner talks to the computer, or how the computer talks to other modules. So, but yeah, so you don't really need this box in order to talk to a car. But this is for me very handy, because I have 2, 4, 6 connectors, so I can plug this wire here or in the back and have an instrument cluster and other modules, and do, as you have seen in my other videos, a multiple interconnection with modules where I have a cluster or so, and then I can do my thing, right? All right, guys, thank you so much. See you next time. Bye-bye.